Right, so we can describe any shape really as a locus or locus. Oh, okay. This topic, of course, we're interested in the parabola. So how do we define the parabola as a locus? And there's its definition. A point will move so that its distance from a point is the same as its distance from a line. So all the ones we looked at in the last one was distance from a point, which gave us a circle. Just distance from a line, which gave us another line. Distance from 2 points, which also gave us a line. But this time we're talking about a distance from a point and a line. And we have special names for these. In this case, I do know how to say that word. It's focus. There's no way it's focus. That would just be silly. All right. So the point, that fixed point, is known as the focus, and that line is known as the directrix. Okay, there's my fixed point. I've given it these coordinates for a reason. So it turns 0A. Very handy choice, it turns out. The directrix, there's my fixed line, which will be y equals minus a. I've deliberately picked those so that this parabola will go through the origin. The origin is forced to be a part of this, because remember we said the distance to the focus, which would be a, is equal to the distance to the directrix, which is also a. So this parabola will be forced to go through the origin. Those distances are the same. Well, there's a point, as I say. The origin would be one of those. There's another. Ooh, and another. And another. And another. It's a very shallow parabola on my diagram, but it does turn out to be a parabola. Some more points. There we go. So it's quite a shallow parabola on my scale, but it is a parabola. Let's find this equation. We'll give one of those points the random coordinates of x, y. And we're saying its distance to the focus. I should have picked another point, shouldn't I? Because that looks horizontal. But remember, it's random, so it's not necessarily going to be horizontal. But distance to the line will definitely be vertical, because we need to have perpendicular distance to the line. Okay. So the distance from P to S will be equal to the distance from P to M. So the square root of x minus 0 all squared plus y minus a all squared is equal to, you know, I've used the distance formula for PM, but I didn't really need to, because it's a vertical line. So it would be whatever that y value is, plus that distance, which we know is a. So that right-hand one should turn out to be just y plus a. But anyway, let's keep going with our coordinate geometry. Square both sides. I've got x squared plus y minus a squared is y plus a. There's the y plus a I was expecting. Expand out. Group together, and we get this neat little formula. X squared is equal to 4ay. So any parabola that goes through the focus, that's either concave up or concave down, can be expressed that way. X squared equals 4ay. And that a, again, why I chose those particular points, a then tells me where the focus is, but it also tells me what the directrix is as well for that particular parabola. All I need to is work out what 4a is. So, as x squared equals 4ay, we know every one of those parabolas will go through the origin. Its vertex will be at 0, 0. Its focus will be at the point 0a, and its directrix will be y equals negative a. So the key is I just have to find out what a is. There's a thing called a focal length. Focal length is just simply the distance from the focus to the vertex. So it always turns out to be a. So here's a parabola. We don't normally see it written this way. Normally we would see it written as y equals x squared on 32. But I've put it in the format x squared equals 4ay, so I can pick it out easily. So we want to find the focus, the focal length, the directrix. The key is working on what a is. Well, in this case, 4a is 32. A is 8. I now can answer the question. Well, the focal length is 8 units. Now, there's my parabola. I know it's a happy parabola because it's x squared. 0, 0 is the vertex. I know the focus will be a focal length up at 0a. So the focus is 0, 8, and the directrix will be a focal length below. And you might be thinking, well, why are you bothering with this diagram over here? We know it's going to be y equals minus a and naught a. Because what the next thing we'll end up doing is, well, what happens if the parabola is not at the vertex? And so imagining the picture and focal length above and focal length below is probably an easier way of doing those sort of problems. So y equals 4x squared. That's how we're used to seeing it. So before I can work it out, I need to get it in the form x squared as the subject. So we want x squared equals 4ay. So I just rearrange it. It becomes x squared is a quarter y. So this one, 4a is a quarter. A is 1/16. So okay, focal length is 1/16. There's my happy parabola. The focus will be 1/16 above, so it's at 0, 1/16. And the directrix 1/16 below, y equals minus 1/16. Other way around, they've told us some information about the parabola. They want to know the equation. So the focus is 0, -2. The directrix is y equals 2. So I know a is -2 because the focus is at 0, -a. This parabola must be upside down when you think about it. Because when it was a happy parabola, the directrix was below the focus. But this one, if you look at the y values, the directrix is above the focus. So the parabola must have been turned upside down. And that's confirmed by a being -2. Because when we substitute it into x squared equals 4ay, we get x squared equals minus 8y, or if you want it as y the subject, y equals minus 1/8 x squared. So it's an upside down or concave down parabola. But hang on, look at the second one. Directrix is x equals -3. Well, that's weird, because we said directrix was y equals. What's happened to this parabola? Yeah, it's on its side. So the only difference is focal length will still be 3, but instead of being x squared is 4ay, it's going to be y squared is 4ax, because it's on its side. So there we go, y squared is 12x for that one. So that was nice and easy because it was at the origin. So we could always use that formula, 0a for the focus, y equals -a, and we're going to get the answer. What happens if it's not at the origin? This is where we can use our shifting idea. Then we group the horizontal shift with the x value, so it becomes x minus p all squared. And we group the vertical shift with the y value, just like we did with the circle. Remember when the circle, the centre wasn't at the origin, we would say, oh, well, it's, I don't know, for example, x minus 2 all squared plus y minus 3 all squared equals something. And when you, well, the centre's moved to 2, 3. Same idea. So the vertex now would be at PQ, wherever we've shifted this parabola to. The focus then will be a focal length above the vertex. So the x value is going to stay the same, but the y value would be plus a. We've added a on. The directrix is a focal length below the vertex, so it'll be q minus a. A is still going to be the focal. That hasn't changed. We haven't changed the shape of the parabola. All we've done is moved it. So the actual length will be the same. So let's try one of those. The vertex is 3, 1. The focal length is 2 units. Okay, there we go. X minus 3 all squared is equal to 4 times 2 y minus 1. If I had said the vertex was 0, 0, you would have just gone x squared equals 4ay. And they've told you a is 2. The only difference here is we've got a shift happening. And so grouping with the x and grouping with the y, we take into account the shift. So we've moved the x 1 to 3 and the y 1 to 1. There it is. It's probably good enough for an answer, to be honest, but we can expand the whole thing out and make it look like an equation we're used to seeing. Let's see what it looks like. X squared minus 6x, we tidy that up. There we go. Eventually we got it. That would be y equals 1/8 of x squared minus 6x plus 17. Of course, that's just one possibility. I never actually said this was concave up. All I said was the vertex was 3, 1 and the focal length was 2. So it's possible it might be concave down, in which case A would be negative 2. See, focal length is always positive because we're talking about a distance. So it's still 2, but A might have been negative 2. So what would happen here? Let's expand that one out and we get, there it is. So the other possibility for this one would be minus 1/8 x squared minus 6x plus 1. Mind you, technically I never said it was concave up or concave down. It could be on its side. So it might be y squared equals 4ax. So I could have y minus 1 squared equals 4 times 2x minus 3. Let's see what we get there when we expand that one all out. There we go. Eventually we get that one. Of course, who's to say the parabola was going that way? It might go that way. So I could also swap them round and have negative 2. And now, yeah, I would hope to think, or like to think, that in a test they're going to give you a bit more information so we don't have to go, oh, hang on, it could be this. Because actually, when you think about this, there's an infinite number of possibilities. I've only taken up the possibility that it's vertical or horizontal. Probably could be at an angle, for all I know. And so there's actually, the way this question's worded, there's actually an infinite number of possibilities. No, you wouldn't have to put all infinite down. Well, let's try one which might make life a little bit easier for ourselves. This one I've got no choice. I know what it's going to be because they've told me the directrix is y equals. So if that directrix is horizontal, then I've got a standard either concave up or concave down. Just depends where the focus is. So the focus is actually below the directrix. So there we go. I know that the directrix will be a focal length above the vertex, but I don't know what the vertex is. But I do know what the focus is. And the focus would be A units below. So between the directrix and the focus, I've got 2 focal lengths. So I know that 2A will be the distance between the focus and the directrix. And this is why I like to draw a diagram so I can see for myself. Oh yeah, okay, it's going to be 2 focal lengths. So 2A equals 2. I made the numbers nice and easy for ourselves. Focal length is 1. I know the focal length. The other piece of information I need to know is the vertex. Well, I can work that out now because it's going to be a focal length above. So the vertex is going to be 2, 9. I can now put it into that general formula. X squared equals 4ay, but in this case, a is negative 1, although I've put the negative at the front there. And then I've taken into account the shift to the vertex. So the x we've shifted to 2, and the y was shifted to 9. What does this end up being? Eventually, let's say, that second line's probably good enough for an answer. It's probably all they're really looking for. But if we do go to y equals, which we're used to seeing, there it is, y equals minus a quarter, x squared minus 4x minus 20. And that is the only possibility for this one. Ooh, they've given me an equation. We're going to find the vertex, the focus, basically all the different information. Okay, 12y. I need to rearrange this in the form so that the coefficient of x squared is 1 and the coefficient of y will be 4a. Now at this stage, the coefficient of x squared is 1. So therefore, I know 4a is 12 for this question. Okay. But if we don't immediately see it, let's actually, what's the word? Complete the square. Complete the square, that's what I'm looking for. Because I know I'm going to end up with x with a shift all squared. So I know I need to complete the square on the x. So let's just look at the x's. I've moved the 3 to the other side. So x squared minus 6x, it'll end up being half the coefficient of x squared will add on. So in this case, we're going to add 9 onto both sides. The right-hand side will become x minus 3r squared. So I know where the vertex horizontally has been shifted to. Now let's group the left-hand one. 12y plus 12, factorise that one. So there we are, 4a is 12 as we said before. But now I also know my vertical shift as well. So that should be enough to get me all the information I need. Okay, there's 4a. 4a is 12. So focal length turns out to be 3 for this one. So focal length is 3. Vertex, I've shifted across 3 and down 1. So the vertex is 3, negative 1. Draw myself a little picture just to confirm it. It's concave up. There's my vertex. Focus is a focal length above. In this case, what was it? Yep, there, 3. So if I go up 3, the focus is 3, 2. And the directrix, focal length below. So it'll be y equals negative 4. Whoa. Ooh.